Hey class, section 6, one of my favorite lessons of all of the teaching that I do in Algebra 2. Look at the top part of the notes and the answer key to make sure you understand, but we're talking about dividing polynomials. A polynomial divided by another polynomial, and it's pretty great. But before we get there, can I refresh your memory about regular long division? I'm just going to make up a problem. I've never done this problem before. Probably no one has done this before. I'm going to do 23 divided into 5, 9, 2, 3, 1. Ugh, gross, right? Well, to do this division, what I'm going to do is I'm going to see how many times 23 goes into 59. And I think that's probably twice. That would be a 46. Subtract, that's a 13, 2. How many times does, and then I bring down the 2, right? And then I say, well, what times 23 gets me close to 132? And that's probably a 4, maybe a 5. 5 would be 115. And I subtract these. That's going to be a 7, 173, and I continue on going down. And it very well may, I very well may find out that there ends up being a remainder, right? So I go blah 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 with a remainder of blah blah blah, whatever it is. Oh, there's a bubble. Hold on, I'm almost done. So that's the process that we have with long division. Well, what if it's polynomial long division? How does that work? Well, I'm glad you asked. Let me see how it works. What we do for this number 5, I will set it up the same way, where I have x plus 8 divides into x squared plus 3x minus 43. And I always focus on the leading parts. Always focus on the x. And I ask myself, I want to line up things so we can subtract. So I ask myself, what times x gives me x squared? Well, that would be just plain x. So I'm going to put an x right up here. And now x times x plus 8 is x squared plus 8x. And then do you remember what I did in long division? Didn't I subtract these? So I will subtract them both, and what we'll find is that these first things cancel out. They'll always cancel out. If they don't cancel out, you've done something wrong. So those are gone, and now I just have to combine these. A positive 3 and a negative 8 makes a negative 5x, and now I bring down the minus 43. And then I start the process again. I look at the x and this leading part right here, and I ask myself, what times x gives me a negative 5x? And that is a negative 5. A negative 5 times x is a negative 5x. A negative 5 times an 8 is a negative 40. And then I again subtract. And when I subtract, that means I sometimes have to add the opposite. The minus right here becomes a plus. The minus right here becomes a plus. And do you notice that again, those first things cancel out? And then I combine these together. I see a negative 43 and a positive 40. That gives a negative 3. So my remainder is a negative 3. Yay! So I have done this division. It turns out that x squared plus 3x minus 43 divided by x plus 8 is x minus 5 with a remainder of negative 3. Cool. But here's what the people in that big gray building discovered a long time ago, and this was amazing. What they discovered, or what they decided, not discovered, they decided that there's a whole lot of wasted effort here. Half of what we wrote down, we crossed off anyway. And every time we did some multiplication, we had to go through and then turn everything to the opposite by subtracting it. And they said, what if we came up with a completely different way of doing division? And this is what they did, okay? So hang on to this. This is going to go fast even with the video. What they did is they took all, and this is the same problem. What they did is they took all the coefficients, 1, 3, and negative 43, and they wrote those down as 1, 3, negative 43. and they put a big box around it, leaving a bunch of room to fill in. And then they took this and they set this equal to 0 and solved for x. And that gave -8, the opposite of this. And because it's the opposite of this, whenever we do the multiplication, the subtraction is already built in. And this is the process that they did. They bring the 1 straight down and multiply. -8 times 1 is -8. Then they add these together, get -5. -8 times -5 is 40. They add these together and get -3. That's your remainder. This is x minus 5. And there's our answer. X minus 5, the remainder of -3. Wow, that is really slick. And I want you to notice about how this works. Do you see this 3 and -8 giving -5? Do you see how that showed up over there as well? And do you see the -43, 40 giving -3 also shows up right there? All they're doing is recognizing that, hey, and if we keep going with this, taking up more and more room, why don't we just shove all these numbers, these sets of 3 numbers repeatedly, why don't we just shove them all up and keep them organized that way? And then the only thing to remember is, wait, there's some variables involved here. Well, because this started out as squared, it's going to end up 1 less than squared to be a plain number. So that's the process of synthetic division. Let me do it again with a more complicated one. You can see how it goes. I've got to find a complicated one. Yeah, let's do number 8. You might want to pause it a couple of times through and see if you can do what I do right here. But I'm going to start by recognizing that the polynomial is in proper standard form. The exponents descend. If these were switched around, you'd have to rearrange it. Otherwise, synthetic division would all be wrong. So I see that it's a 3, 2, 1, 0, and that's good. So I have coefficient of 1, coefficient of 5, coefficient of -7, coefficient of 2, and put a box around it. And if this were set equal to 0, I would find that it's 2. Or because it's a -2 here, I know that the opposite of that is 2. And now I'm going to go through and do my synthetic division. If you want to pause it right here, you can try it. Otherwise, keep watching. All right, so the process is to bring numbers straight down and multiply diagonally. 2 times 1 is 2. And then I add vertically. 5 plus 2 is 7. And then I multiply diagonally. 2 times 7 is 14. Then I add vertically. -7 plus 14 is 7. Then I multiply diagonally. That gives me 14. 2 plus 14 is 16. And this is my remainder. And because it started off as a cube, this is a squared. 1x squared plus 7x plus 7 with a remainder of 16. I don't need the 1, and I guess these are y's, aren't they? So sorry about that. So really my answer is going to be y squared plus 7y plus 7 with a remainder of 16. Woohoo! Wow, that is pretty slick. So play with that some and see what happens as you go through, and we'll see you next time.